Okay, welcome to day 4, graphs of sine and cosine. We're going to take everything we've been doing the last few days with the sine and cosine functions, and we're actually going to make a graph. One major thing that we're going to do is that on our graph, our input will not be degrees, it would always be radians. And we're going to use a unit circle here on the right. I know I made it kind of small. We're going to plot all these values. Basically the angle in radians, comma, whatever the value is. But we're not going to use every single one. That's way too much to do. We're going to use every quarter circle. So that's when theta is equal to 0 plus or minus pi over 2 plus or minus pi plus or minus, ooh, that's terrible, plus or minus 3 pi over 2 plus or minus 2 pi, so on and so forth. So we're really only looking at these values right here. And then we're going to kind of figure out what the graph looks like. Remember, cosine is the x value and sine is the y value. If you go to the portal and pull up the notes, the blank notes, you'll see where it says the online animation. You could click on it. You can see how they're drawn on the internet. It's quick and easy. You could do that. So I'm going to do the cosine of theta. That means I'm looking at all the x values from this. So it's 0 radians. My cosine is 1. I'm going to plot that point. At pi over 2, I have a cosine of 0, the x value. At pi, it's negative 1. At 3 pi over 2, it's back to 0. And at 2 pi, it's back to 1. And basically, this repeats over and over and over again. 0, negative 1, 0, 1. I could do it in reverse. 0, negative 1, 0, 1. And it says right here, no zigzags. I want this graph to be wavy. Think roller coasters. You draw zigzags on a quiz or test, I will take off points. Do the best I can with the stylus. See, I'm making them wavy, thinking roller coaster. You get to the bottom of the roller coaster, it's not sharp. It's a nice curve. Same thing with the top of the roller coaster. So there is my graph of the cosine of theta. The one thing I do notice is that there is a pattern to these dots. If you think about what we did, we started with the first dot right here at the angle was 0 radians and my value was 1. And that was actually the maximum value of the whole graph. And then I went to the mid, and then I went to the minimum value, and then I went back to the midline. I repeated it all over again. If you look at numerical values, this graph went from positive 1 to 0 to negative 1 to 0. And I repeated it all over again and again. So with this pattern, cosine will start on the y-axis. The first point on the y-axis will be at its maximum. It goes to the midline, goes to the minimum, goes back to the midline, and repeats the pattern over and over and over again in both directions, forwards and backwards. So with that idea, if we have a positive number in front of cosine, the graph starts at the maximum and goes down from there. But if we have a negative number in front of cosine, it starts at the minimum and goes above, because a negative number in front is at a value, and that a value is a reflection, flips it upside down. So let's look at some of the details here. Change it to red. The domain, or the x values, and this graph goes forever left and right, so it's all real numbers. The range, well, the lowest number is negative 1, the highest number is 1, and they're both included. And this has a special name. Now, we've been dealing with graphs that have been going up forever, down forever, or leveling off. This doesn't either. It doesn't go up forever or down forever or level up. It oscillates back and forth, and it's a bounded graph. It's stuck between the numbers -1 and 1. The symmetry, if you look carefully, right here at the y-axis, it folds neatly over the y-axis, so it is even symmetry. The period is, how long does it take to complete one cycle? So if you want to look at a cycle going from this dot back to here again, its period from this dot, max dot, to the next max dot is one full circle, or what we call 2 pi. The amplitude, that is the height of the sine or the cosine wave, and the amplitude, let me shrink this up a little bit, the amplitude is from the maximum to the midline, or from the midline to the minimum, and this amplitude is equal to 1. The midline is a line that runs through the middle, horizontally through the middle of the graph, and this midline is y equals 0. Please put y equals 0. And then we have to look at the x-intercepts, and we have them here, 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 here. It's like every other dot. I see a nice little pattern. It looks like plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2. I see a nice little pattern. So I'm going to write down this pattern as, it's going to be n times pi over 2, where n is an odd number. Anytime you take an odd number for n, 1, 3, 5, 7, that will be an x-intercept on this graph. So we're going to be using these parent graphs. These are two. This is another parent graph, and we're going to do the sine. These are parent graphs that we do, that we did in Unit 3A. We should know parent graphs, and then we could make transformations to them. We're going to do a couple of transformations today, the easy ones, but we need to know these graphs. So please know this pattern for cosine. We'll move on to sine, and I'm going to use these values up here. You could keep your paper and see it. I'm not going to. I'm just going to do it from here, and I'm going to make blue dots again. And at 0, at theta equals 0, sine is equal to 0. At pi over 2, it's equal to 1, back to 0, down to -1, and back at 2 pi, back at 0. And this is a pattern that is going to do middle, max, middle, min, middle, max, middle, min, middle, and doing in reverse. Again, I need to make it wavy, so nice waves. Think roller coasters. Think about what it means to ride a roller coaster. You don't have sharp corners on roller coasters. That would hurt. So here's the graph of sine, and again I have this pattern. This pattern that I see starts at the midline, goes to the max, go back to the midline, and goes to the min, starts all over again. If you want to put numbers to it, it goes from 0 to 1, back to 0, down to -1, and repeats over and over and over again. Therefore, if we have a positive sine graph, a positive number in front, it starts at the midline and goes up from there. If I have a negative sine graph, it starts at the midline and goes down from there, whether that number is positive or negative in front of it. Now let's go back to these details of everything we did, just like we did for cosine. Well, the domain is all real numbers. The range is still -1 to 1 because it is a bounded function. It is stuck between the boundaries of -1 and 1. The symmetry this time is odd. If you look at it, you could flip it 180 degrees. The period, or one cycle, is still 2 pi, one full circle. The amplitude from the midline to the max is still 1. The The midline is y equals 0. That hasn't changed. But now I have to look at these x-intercepts. And these x-intercepts I see here are here. I see them as 0 and pi and 2 pi. So one way to look at it is just n times pi. That is one way to look at it. I'm going to use the same idea I did before, and we really call it n times pi over 2, but now n is equal to an even number. 2 pi over 2, 4 pi over 2, 8 pi over 2. Anytime you have an even number, those are the x-intercepts or zeros for this graph. You notice basically all these ideas that we did before are the same except the symmetry and the zeros. And if you look very carefully between these graphs look very, very similar. The only difference is that the cosine graph or the sine graph is shifted pi over 2 from the other graph. That means there's a little bit shifting left or right by pi over 2. If we recall, pi over 2 in degrees is 90 degrees, and we talked about cosine being the complement of sine. That means there's a shifting of 90 degrees, if you see that in the picture. Now the only transformations that we're going to work on today are the two easy ones. Those are the vertical transformations, the A and the D, the A and the D. Okay? And they do two things. A is a vertical stretch. If it's negative, it floats over the x-axis. The D is the translation up or down, and they lead to two properties. The D at the end is the midline, and I tend to draw this first. I draw the midline first across the graph. So even though it's at the end, to me, I might as well draw that midline first. Second thing I do is the amplitude. Now the amplitude is just a positive number, cannot be negative. And I use the amplitude to mark off where the max and minimum values are on the graph from the midline. So the max and min are just up and down from the midline, whatever the amplitude is. And then we'll have minimums and maximums and ranges and this and that, all based on what's going on in the picture. That's what we're going to do vertical. They're the easiest two to do. So we're going to do this problem, and right now I see I have A and a D value. And I can tell right away that the midline is Y equals, gotta find my eraser, Y is equal to -1. So I'm going to draw that across the page. Y equals -1 is my midline. And if you think about it, I made the letters easy. A for amplitude, and I call it the midline, the D value. My amplitude is this number up front. It's 2. That means I'm going to go up 2 from here and down 2 from here. And this is my max, and this is my min. And therefore my range is from -3 to 1. And this is a positive cosine graph. It's a positive number, so it's a positive cosine. That means I start at the max and we'll go down from there. So my first dot on the y-axis will be at the maximum. Then I go to the midline. Then I go to the minimum, max, middle, max, middle, minimum, middle, max, and I do it in reverse. Okay? And I have this graph that I draw very wavy. Please do not draw zigzags. I will get mad. And I'll take points off for quizzes. And there's your graph. That is the graph of 2 cosine of theta minus 1. The next graph is going to be a little bit different. And I have an A and a D value. The midline The d-value is y is equal to 2.5. Okay, well, I made it nice. I made a nice little y equals 2.5. My amplitude is 1.5. I know there's a negative sign there. That'll matter later. So go up 1.5, go down 1.5. Here's my max. Here's my minimum. My range is from 1 to 4, based off my max and min. And this is a negative sign graph, which means I start at the midline and go down. So my first point on the y-axis has to be at the midline, right here at 0, 2.5, and then go minimum, middle, maximum, middle. Notice every time I draw a new dot, I'm just going one square over to the right or to the left. I do this pattern in reverse. And I have this graph, again very wavy, to the best of my ability using a stylus on a tablet. And there we go. There's a nice little sine. This is the graph of negative 1.5 sine of theta plus 2.5. Finally, I want to think about the other way. I want to write the equation and go, how can I work this in reverse? So the way I can work this in reverse is thinking, what do I need? I need a midline, and I need an amplitude. Well, for me, the midline is the middle of the graph, and it's actually the middle of the max and the minimum. So what can I do? I could do the max plus the minimum and divide by 2. I should be able to find the maximum and the minimum. If I look carefully on this graph, looks like I have a max equal to 4.5. Looks like I have a minimum equal to negative 0.5. So when I do 4.5 plus a negative 0.5 over 2, I get 4 over 2. So I get right here at y equals 2, y equals 2 is my midline. And it definitely does look like it's the midline of the graph. Well, that's my d value. Now when I want to find the amplitude is from the max to the midline. And if I look at this distance from here to here, I notice this amplitude. This is equal from 2 to 4.5. I get 2.5 as a result. Well, it looks like I have the two things I need. I have my amplitude, I have my midline. This is the A value, this is the D value. Now the other thing I need to know is recognize what type of graph it is. If I look carefully at this graph starts at the midline and goes down from there. So it starts on the midline. It has to be a sine graph, but not only is it a sine graph, it's going down from there. So it's a negative sine graph. So the whole equation of this is going to be y equals negative, well, amplitude of 2.5. Let me leave some space. Y equals negative 2.5 sine of x plus the midline of 2. And that is the equation of that blue graph.